Welcome everybody to episode 91 of Axioms on Trial. As always, if you guys can give me feedback, if you can hear me okay, let me know. I don't have a lot of news. I think we'll probably jump right into it. Today's guest is Daniela Perez. She's a professor of astrophysics. And we're going to be discussing the Kalam argument from the perspective of science and physics, and then we'll see how everything plays out. So I'm going to bring her right in. Hello everybody.
Thank you very much for the invitation, Cis, to your show. It's a pleasure. Well, I will introduce myself. My name is Daniela Perez. I'm a researcher in Argentina. I work in astrophysics, basically on black holes, black hole astrophysics. I work on different aspects of black holes. In cosmology, black holes in the context of alternative theories of gravitation. And well, my master thesis, I was interested in the concept of causality in cosmology. So I made a work with the Kalam Cosmological Argument. Of course, that is philosophy. That's what I would like to talk to you today. So the perspective that I'm going to offer is from a scientific point of view. Just I wanted to make clear that I'm not a philosopher. I'm just interested in philosophy, and I will give the perspective from a cosmologist.
Great. And I'm not a physicist, but I'm very interested in physics, so this works really well. So again,
Great.
Thanks again for coming. And so guys, we're having some internet issues a little bit. So just stick with us. Do
you want me to shut down the camera?
Yeah, try turning off the camera and see if that makes the audio better.
Okay, I have to do it now.
Yeah, I can hear him a lot better now.
Works. Okay.
Can you guys in the audience hear her better as well? I can hear her better, but I'm not sure for you guys.
Okay.
Let me know in the comments.
I'm sorry.
No, it's all good. It happens. I've had a lot of issues with internet as well. My audience are well aware of all the crashes that my computer has had. So
okay.
But yeah, I think it works better. And in case there's any issues, you can always come back in. But okay, so I'll share the files you sent me to the stream.
Okay,
great. So
the
Kalam Cosmological
here there is this. Yes, the Kalam Cosmological Argument. Well, here's the bit introduction. I work as a researcher in the Instituto Argentino de Radioastronomía that is in Buenos Aires, Argentina. And the institute where I work is the main topic is radio astronomy, but there is a part of the institute that is dedicated to research, theoretical research in black holes, cosmology, theoretical aspects of black holes, many other astrophysical phenomena.
Okay.
So, well, now we can go to the next slide. Okay, so what is the context? Why the Kalam Cosmological Argument? So many of us, since the beginning of humanity, I will say, there are some basic questions that we have been asking ourselves, such as why the universe exists, if the universe has a cause, and if the universe has a cause, if there is a free agent that maybe we could identify with God, that this God of the monotheistic relations, and this free agent, if this free agent could be identified with God, if this God is the first cause, which is the one that created the universe, who gave rise to the universe. So in order to answer these very deep questions, many philosophers and thinkers through the centuries have tried to devise arguments in order to prove the existence of God. So nowadays, we can ask ourselves if science could give answer to some of these questions from a scientific point of view. And in particular, if we could analyze from a scientific perspective some of these arguments. In particular, what I'm going to present today is the so-called Kalam cosmological argument that was introduced by Al-Ghazali in the 11th century, and that it was reformulated in the 20th century by William Lane Craig. So if we could see the argument, please. So what is important to notice is that the Kalam cosmological argument is a deductive argument for the existence of a cause or a causal agent of the universe. So it is called a posteriori argument in the sense that the true value of the premises, we should know the true value of the premises from our knowledge of the world. In this sense, it is called a deductive argument. So the argument goes as follows. We have the first premise that says what begins to exist has a cause of its existence. The second premise of the argument is the universe began to exist. So the conclusion, therefore, of the argument is the universe has a cause of its existence. So what we are going to do is to analyze this argument. We are going to analyze the logic structure of the argument, the semantic structure of the argument, and to see if this is correct or incorrect in the light of science. So first, let us analyze the logic of the argument. So we go to the next slide. What I was telling you is that it has two premises here, 1 and 2, and then a conclusion, okay? So if we denote by P1 the first premise, that is whatever begins to exist as a cause of its existence, that's the first premise. Then we have a second premise, the universe began to exist, and the conclusion, the universe has a cause of its existence. I'm sorry. So all this that I have said with words, we can use logic or logic notation in order to make it more precise. So in the box that you can see on the right, you can see these logic symbols. So here where we say P1, that is this symbol for all x, that means that for all the things that exist, yes, that will mean that the value of x is anything that exists. And in particular, this b that I have here, it's a function. And this function, when you evaluate this function on an x, that is a thing, that means that is the existence of the thing. So the function b stands for whatever exists. So for all things that exist, then what we have, this c that we have here, this is another function that has two arguments, x and I. This c will mean cause of existence. So this is the way we can this is the symbology for the first premise. So then if we go to the second premise, here we have, no, I'm sorry, the second premise, not the slide. Thank you. Here, P2, we have B of sigma, this Greek letter sigma. B, I guess that we are losing the connection. I don't know if you can hear me well. Do you hear me well?
You're breaking up a little bit. It sounds a little bit robotic.
Yes.
For some reason,
okay.
Okay. It comes in and out for some reason.
Okay.
I think I hear you a little bit better now. I'm not sure. It must be the connection, but we can more or less still hear you. Okay.
Yes. Okay.
Do you
If
go ahead?
yes,
Sorry, what were you saying?
please tell me. No,
Oh.
that if you have any questions while I'm explaining, please stop me.
Sure. No, I'm following you so far. Can you guys
Okay.
understand her? Okay. But yeah, if it starts to get worse as far as the quality, I'll let you know, and maybe you can sign in and back out again.
Okay.
But it's not too bad right now. I don't think.
Okay. Well, I will go on then. Well, in the second premise, we have again this B function, and this B function is it stands for existence or begin to exist. But what we are, this sigma that we have here represents the universe. So the universe began to exist is represented by this B of sigma in this logic notation, because B is the function that stands for begin to exist. So when you evaluate this function on this symbol sigma that represents you, we are saying the universe began to exist. And then if we go to the conclusion is P1 and P2, then what we deduce is that the universe has a cause of its existence, because this C that we have here represents the causality of the universe, because it's evaluated in sigma and some E that will go on this later. So when we write this argument in logical notation, it's correct. So it's okay. But the main problem here, and what I would like to discuss, is what is the semantical model that we are going to propose. So what is the meaning, or what do we understand but begin to exist, causality? Yes, what are the definitions for causality and begin to exist from a scientific point of view? Okay. Okay, so in the first premise, we say whatever begins to exist has a cause of its existence. So the question is, what is to begin to exist? Okay, so we have maybe a notion in our head of what it could be, but here we need to be precise. So if we go to the next slide, we can try a first definition. For instance, we can think that X, with X, I mean a thing. You know, I'm not making a particular thing, but just something in general. When we say X begins to exist, if X exists at a time t, and there are no instants immediately previous to t for which X exists. So here I'm making a cut from t and t positives, X exists, and before t it doesn't exist. So we have here a sharp cut between existence and non-existence. The problem that we have with this definition is that whatever begins to exist starts in a discontinuous way. It's very difficult to say at this instant something exists and just an instant before it didn't exist. And we can think of many examples. For instance, when we take humanity, okay, we can say that humanity didn't exist 50 million years ago. But can you mark the instant of time in which humanity started to exist and the immediate previous instant it did not? Can you make such a sharp cut? No, it's not possible, because to begin to exist is a continuous process that we cannot just very sharply indicate. So I propose that this definition for begin to exist is not adequate.
Real quick, Ada is asking in the
Yes.
comment section, who is Gustavo Romero?
Gustavo Romero is he is astrophysics, scientific philosopher here in Argentina. He has worked a lot on philosophy, scientific philosophy. He has written a book on scientific philosophy in Springer and many articles. He knows a lot. He has been doing research on these topics. And of course, he's an astrophysicist by career. He's a physicist in many fields.
Great.
And we have done in philosophy some works, and mainly he's my main co-author of all my works in astrophysics.
Gotcha. Okay.
So, well, and the second definition that we are going to propose here is, since this doesn't work well to mark a very sharp, to mark, like T, and at T is something start to exist, and it doesn't work very well. So here I'm posing another definition, which will be the one I'm presenting here. That is, X exists at a time T. So, for instance, I'm existing now, you are existing now, this date, and there is a time interval. This delta T means a time interval, which is greater than 0, such that there are no instants of time prior to T minus delta T at which X exists. So this is a way in which we can define begin to exist. So now that we have a definition for begin to exist, we can ask ourselves if there are things that begin to exist but that have no cause. Okay, because here in the first premise of the argument says whatever begins to exist has a cause. But are there things that doesn't have a cause of existence? So that's why we have to give a proper definition of causality. Yes, and this definition of causality that I'm presenting here is from a scientific perspective. So this function C of X and I here are two things in the world. For instance, it could be, I don't know, a computer, a cell phone, a person, star, anything, things in the universe. So, no, I'm sorry. Okay. So,
sorry, I didn't mean to click that.
What we have,
I think froze for a second.
Okay. Okay. So, what we need to understand is what are the domains of these variables, X and I, and what type of relation is cause. Cause is a relation between things, between events, between what? So what we have to understand is, from a scientific perspective, in the world we can say that there are things and that things have properties. Again, for example, what we understand by a thing, a pencil, something that has atoms, but also we can say that an electromagnetic field is also a thing, the sun, stars, and all these things have properties. For instance, we can say that a car has a position and a velocity. That will be a property. Or, I don't know, a pencil or any other thing, we have a temperature. So these are properties of things. So what we can say is that if we have a thing and we have a collection of properties, the things have a state. And what is the state of the thing? Are the properties of that thing in that instant. There are things in the world that are extremely complex. For instance, in my case here, if I have to mention all the properties that I have now, for my temperature, my position, my velocity, and so on, but these are that if I can say which are all the properties that I have now at this instant, I'm telling you which is my state. So, but I change all the time. We all change all the time. So this changes in time is what is called an event. That is an ordered pair of states. For instance, if I am in position 1 and then I go to position 2, this change in my position is an event. Okay? So these events that we have events but here I will have to introduce a bit more structure, but I haven't put it on the slides. We can think that what is the relation events in the universe, how these events are related, and they could be related in a causal way in this sense. Suppose that we have a thing X and a thing E. A thing X causes something in a thing E because it's acting on this thing. But the property of causality is between events, is not between things. And in order to act on one thing on the other, it needs to transfer energy. So all the changes that we see in the world, these are events, and the way these events are generated could be by causality. That means because one thing is acting on another thing, but it's not the only way events could be generated in the universe.
I want to ask you something real quick before we move on to the next slide, because you said something interesting there. You said that the causality is not between things, but between events.
Yes.
How would you define the difference there between the two?
Because a thing, it's an ontological difference. A thing is something like, for instance, as I was telling you, something which has matter or not is, as I was telling you before, something that has properties. For instance, you can think of an atom, an electron, you, me, is a thing that has properties. But these properties of things have values. Okay, so as an example, I can say, I don't know, now here I'm at a given position in space. Okay, that's a property. Well, my position in space, that number, is called my state. Okay, but my state can change because I can go to the other room and my position in space will change. So these changes in states are what we call events.
Gotcha.
Okay, so that's why this is important to remark that causality is it's a relation between events and not things. One event is related to another event. Of course, there are things, the events don't happen, or sometimes some sort of events are due to a thing, but what I wanted to discuss is that in order to generate events, it's not necessary, or causality is not the only way of event generation. There are things that happen in the world that are caused not by anything else, okay? So I guess that here, that's what I wanted to say, that causality is a relation between events, but not things. It's a way that you can generate events. So in order to have a causality relation between two things, you need that one thing to act on another thing. For instance, here, I just forgot the name in English for this type of game.
Dominoes.
Dominoes here. So, for example, if you, with your finger, you touch one of the dominoes, your finger is acting on one domino. So there you have two things, your finger and a domino, okay? These are the two things. But the event is another thing, is the change of the state of the domino, the positions in the change of the domino. So this is a causal relation, because one thing, your finger is acting on the domino. So these two things are related. The finger is transferring energy to the domino.
Real quick.
But
I'm sorry, I thought you
yes.
started cutting out for a second.
No, please tell me.
Comment or question from the audience. Alec asks, are these definitions that scientists use, or are they a scientist's take on a philosophical position?
No, these are definitions that we are using. In fact, I was here not talking about space-time, but in general relativity, or all classical theories in physics presuppose one thing, that space-time exists. And what is space-time? Space-time is made of events. Okay, we have, every time we picture space-time, we know with this sheet that is curved, for instance, and you put different things on this sheet and it has different curvature. But what is curved depends on space-time. So all theories in physics are built on these sort of definitions. Okay, so here where I have introduced the concept of causality. So let's recall the first premise. In the first premise, we say that whatever begins to exist has a cause of its existence. But we know that for many events, there is not only one cause for existence. There could be many causes. So just to attribute one cause is somehow incomplete. For instance, you began to exist because of a conjunction of causes, not just because one cause. We take, for instance, the solar system. It began to exist because of many causes. Argentina, this country where I live, again, and some other minimal things like a neural discharge requires multiple causes. So to attribute just one thing to the beginning of existence, it's like we are missing something there. This is one of the problems with the first premise. And the second problem is that causality is one form of event generation, but it's not the only one, because there could be also a causal event. This means that things that happen in the world, but were not provoked by something else. And we have examples in physics, like the decay of the muon. The muon just decay in other particles, in an electron, in antineutrino, and neutrinos in spontaneously. Nothing acts on the muon to decay on these particles. And this is an example of how events can be generated without something acting on that. So not all things that are events generated in the universe occur because of a causal relation. And there is another problem, okay, with premise 1, that we are assuming that all causes have or defects are preceded by a cause. Yes, but it's not really true. Here, well, I'm sorry because this figure on the left is in English. But if we are going back to general relativity, maybe I'm here to be a bit technical. But in general relativity, or even in special relativity, we know that space events in space-time are connected, are related, but not all events in space-time are related one to each other. What I'm drawing here is what it's called the light cone, and this the curve that goes through these light cones in the second picture is what is called a world line of an observer. So imagine that your life, you can draw you were writing in a time diagram your position in space and time. So this curve represents your position in space and time. So you are not related to any event in space-time, but the ones that lie inside your light cone. And that is the reason for that, is that events, or badly say information, cannot be transmitted at a velocity larger than c in general relativity. So some events are related to some others and some other not. So this is what a light cone is telling us. But this trajectory in space-time, because of gravity, could be you can curve your trajectory in space-time, and you can make such you can curve your trajectory in such a way that you can connect your future with your past. And I know that this sounds weird, but general relativity makes predictions about this. This is what it's called closed time-like curves. There are solutions of Einstein field equations where you could have closed time-like curves. So this, as the name says, you have temporal curves. These temporal curves represent the trajectory of observers like us or anything that moves at a velocity that is smaller than c. And these closed time-like curves can be found in certain regions of space-time. For instance, inside curved black holes. You know that black holes are, we have a lot of evidence that black holes do exist in the universe. Maybe you know that a few weeks ago, even gave us.
Sorry, could you repeat the last part again, because you started cutting out again?
Okay. Well, what I was telling you is that holes do exist. These holes are not just mathematical of general relativity, but that they are real entities in the universe. Is that 2 weeks ago, the Event Horizon Telescope collaboration showed the image of the shadow of Sagittarius A star at the center of the galaxy as an evidence of proof that what lies in the center of our galaxy
Oh, I think her internet must have died. Hold on 1 second. There we go. How do can you hear me?
that we are.
I
lost the connection a bit. Hear you.
Okay, I can hear again now.
Can you hear me well?
Yeah, I think so. Yeah.
Can you hear me?
Yeah, I wanted to ask you.
I lost connection like a minute ago.
Okay, yeah, I can hear you better now. I wanted to ask you something about the last thing you just said.
Okay.
Because wouldn't the future interacting with the past lead to a paradox?
Yes, there are many paradoxes indeed. That's why some people think that closed time-like cubes, though they are solutions of Einstein-field equations, they do not represent a real feature in our world. I'm just telling that from the violating anything, we have solution of Einstein-field equation that tell us that closed time-like curves are possible. Yes, but there are many paradoxes like the Grafler paradox, etc., that give rise to many problems.
I see. Okay, I'll move on to the next slide.
Okay. Yes, please. So we, in the second premise, we are saying that the universe began to exist, like we assume like the universe began to exist, but we can ask ourselves, is that self-evident that the universe began to exist? So here we have to make clear what we understand of the universe. So what is the universe? Here I'm proposing this definition, that the universe is the system formed by all material things. And what do I mean by material things? Material things are objects that can change and interact with other objects. So a material thing is my cell phone. I am a material thing. The ones that are listening to me now are material things. But a triangle, a circle, a number is not a material thing. It's an abstraction. And those abstractions cannot change, do not have energy. The universe is formed by all material things. So we know that at large scales, the universe is in a state of accelerated expansion, and currently the model, the best model that we have to describe the universe is the Lambda cosmological model. Maybe we can go to the next slide. Okay, so the current cosmological model is based on certain theories and hypotheses, or the so-called Big Bang, which is in fact a family of theories. And these are that the universe is expanding because we have observed that galaxies were because of the radial velocities of galaxies, we can infer that they are expanding, and not also that the universe state of accelerated expansion nowadays. So we also assume that general relativity is valid. So when we describe the universe as a whole, we are assuming general relativity. We also assume that the standard model of particle physics when we describe the universe. And the Lambda cold dark matter model assumes the existence of something that we don't know what it is, but it only interacts gravitationally. That's what is called dark matter. So the current cosmological model is composed by all these elements. But one of the cosmic the current model is that it's singular. What does it mean? It's singular. That if we go back in time, we go to the past, there is a state in the universe that we can describe with all our theories now. It says that there is a cosmological singularity. Here in this diagram, as what you can see is that the universe is now expanding. In the past, all was like somehow compressed, and this state of where that the universe somehow was very, very small and with a lot of energy, we cannot describe it. Nowadays, we don't have a theory to say what was happening there. So that is why mathematically we say that the model is singular. I wanted to make clear that singularities are not a feature of our world, but a problem that we have in the description of our theories. So something was happening at that moment, but we don't know how to describe it. Maybe with a quantum be able to know what was happening. That's what I wanted to make clear. So maybe if we go to the next slide.
Just real quick, I just want to respond to a comment.
Yes, please.
Bradley writes, I appreciate the scientific facts undercut the Kalam, but the Kalam isn't a scientific argument, and the proponents aren't likely to find any of these objections meaningful. But I don't understand that statement, because if someone's philosophy is outright ignoring science, like where do you make the distinction there?
Yeah.
If it's making claims that are violating things that we know are the case through science, then I don't know what is the value of the argument there.
Yeah, I guess that as I said at the beginning, the Kalam cosmological argument is the deductive argument, and it's a posteriori argument. That means that the value of true of the premises, we know it from our experience of the world, of our observation of the world. So the Kalam argument makes some statements about the world. And the question is, are these statements true or false? Well, what I'm discussing here is, in the light of science, are these statements true or false?
Yeah.
So that's,
I'll move on to the next slide.
What I'm here analyzing as, that the premises, I will get to the conclusion that the premises are false. Okay. So here, well, when I add that the cosmological models are singular, it means that, for instance, use time to describe the universe. We say this galaxy was in this position like 10 million years ago, etc., etc., etc. But if we want to use this time and extrapolate this variable way in the past, we will not, because space and time in the description of generality break down at certain scales. So basically, we don't know how to describe space more than 13.5 thousand. I'm sorry, I just forgot how to say this in English. 13.5 thousand million years ago. There I have it. So we say that the age of the universe is finite? Not really, because what we can say is the universe has been expanding all that amount of time. But we don't know how to describe the universe before that, because our models do not tell how to do it. And we will have to expect, if possible, for another type of theory. Okay. So there could be some other possibilities for the universe. For instance, we can think that the universe that we are living now, that is in a state of accelerated expansion, came from a previous state where the universe was contracting. Imagine, and this type of models that are nowadays studied in science are called bouncing cosmologies. So imagine that the universe was in a very diluted state, started to contract, but then this contraction stopped and started to expand again. And we are now living in the expanding phase. So how could you say, in this type of models, what is the age of the universe? What is when the universe started to exist? That question loses meaning for these types of cosmological models. Okay, so here we have one, and we've analyzed two, and we have made give an interpretation to these two symbols: B symbol, that is begin to exist, and the C symbol, that is causality. And what we have found is that not only the premises of these arguments are false, but that the interpretation of these symbols is different in the conclusion and in the premises. Maybe we can go to the other slide. Because what we have said is that in the definition that we employ of cause needs a thing. Something causes something else in another thing. So if the universe has a cause of its existence, there will be something that is outside the universe that is causing its existence. But this is not possible because the universe is the system of all material things. So there is nothing that is outside the universe. So with the definitions that I have just presented here, we can see that the Kalam cosmological argument is not sound, because the meaning of these symbols C and B is different in the premises and in the conclusion. So what I'm presenting here is that under this model, under the definitions that I have provided here, the argument is not valid. So one important thing that is behind the Kalam cosmological argument is the concept of causality. And the concept of causality is closely related to that of space-time. What I was telling you, that space-time is composed of events. So you cannot have causality outside space-time, because you need events. If you don't have space-time, you don't have events, so you don't have a causal relation. So all of that I'm saying means that we can have we can say that the universe, it's meaningless to say that the universe has a cause of its existence, but the universe might have an explanation. These are two different things, because to explain, is to unveil a mechanism, to give what are the mechanisms behind what is happening. And in fact, we don't know what were the mechanisms that were operating some time ago when our theories do not work anymore. So an explanation for the universe, we need an explanation for the universe, for the origin of the universe, but at this moment we don't have one. It could involve, yes.
I have two questions.
Yes.
One is, what other forms of event generation are there?
Yeah, well,
causality.
Okay, I was explaining before that another form of event generation is a causal, you know?
Right, okay.
A causal, when you have, for example, the spontaneous decay of a muon. Just the muon decays without something initiating the decay, something outside the muon. It just decays. There is no other thing that provokes the decay of the muon.
There's definitely something that is hard from a philosophical standpoint, and certainly a common sense standpoint, to wrap your head around, that something could just happen spontaneously without explanation.
No, but it's different, because it's not. It doesn't. Because you are confusing two things. You are confusing causality with explanation. These are two different things. My definition of causality is a form of event generation. And explanation is something different. Explanation is to give the mechanisms that... okay? So there is an explanation, but it's not causal.
Right, okay, that makes more sense. Also, I wanted to read a comment real quick.
Yeah.
Bradley writes, how do we know that there's nothing outside the universe? We cannot make observations outside the universe, but it doesn't mean there's nothing there.
Okay, yes. Somehow it's true, because in the definition that I have gave, the universe is composed by all material things. So in the realm of science, to say something that is outside the universe no sense. What will we say to say what is to say that something is outside the universe? What will be to be outside the universe? If you have to try to give a definition of that.
Yeah, I think we run into some linguistic problems there. Like, what sense does it make to talk about existence outside of space and time, or let's have a space-time?
Yes, because space and time is, yes.
Yeah, I would say that those are kind of the attributes necessary for something to exist, or for us to talk about existence, right?
Exactly.
And also, Begin to Know writes, from your publication, I take it that you consider the Kalam cosmological argument as failed speculative metaphysics. Is that a correct description of your position?
I don't know if just to put like failed speculative metaphysics, but I just remit to what I have said here, that it makes some statements that are not supported by science. That's what I would say about the Kalam cosmological argument. What I have to say is that it was first it was developed in a time where our knowledge of the world was quite different. It was in the 11th century. So I'm not judging that.
That's fair. You may move on to the next slide.
Yes, please. So I'm just getting to the conclusions here. So what we can say is that the first premise of the Kalam argument is false. That the first premise says whatever begins to exist has a cause of its existence, and I have provided several examples. Causation is not the only way of event generation. When something begins to exist, could have multiple causes of existence, for instance. And the second premise that says the universe began to exist is not supported by current scientific evidence. What we can describe is the current phase of expansion of the universe, but not beyond that, and that's it. So that's why the yes.
Bradley, well, I'm not sure what you're referring to there. Her definition excludes the possibility of the multiverse. It's not a good definition. I'm not sure what definition he's referring to, though, or why he thinks.
Yeah,
so.
I don't know. Yeah, the thing is that in the definition, how do you know the possibility of the multiverse? It's a good definition. It's not a good definition, but my definition of what? Of the universe? What definition are you referring to?
Your definition of the universe.
Yeah, but I guess that I don't know what you mean by multiverse, but the multiverse is inaccessible to us. How do we prove the existence of the multiverse? We live in the universe, access the other universes. So
yeah, I was going to ask you about that. Like, how much of the idea of the multiverse do you consider scientific?
In my work, I do not consider the multiverse that is well formulated,
Sure.
because how can we have to these other multiverses? I can think of 10,000 universes that are existing parallel to ours, but how can we prove the existence of these other universes? What do we mean by multiverse? I don't know. If someone could provide me a definition on this, that.
Any comment on CC model by Roger Penrose?
Yes, here the CC model is the cosmic cyclic cosmology. This is an alternative to the Bang model or the family of the Big Bang models, because in these cosmic cyclic models, the universe goes from one cycle to another cycle to another cycle, and it's a possibility. The problem with these models is that the entropy of the universe increases in each cycle, and that's a problem that it needs to be solved. That's one of the main objections to this, to the model of Penrose. But of course, it's in this case, it adds to this argument, because when in the second premises we say the universe began to exist, the model of there are other possibilities for the universe, and the Penrose model is one of them.
Are you aware of whether or not William Lane Craig has responded to any of these arguments?
I'm not aware if he has. I'm not really sure. I guess he did not respond, at least to our own work. But really, I'm not aware of what he has done later.
Okay. Need me to move on to the next one?
Oh, but I guess that we have just come to the end. So of the presentation of the slides. Okay, perfect. Thank you very much for your attention.
Yeah, thank you.
Well, of course, you have been making a lot of questions, and we can discuss any other aspects that you would like. Yeah, thank you
so much for going over that. This is more of like a philosophical question, and I don't know whether or not you think you can answer it. It's just more of my curiosity.
Okay.
I mean, do you agree that physics is telling us that ultimately existence can be narrowed down to one type of substance? Like, I'm guessing that most people in the sciences are physicalists, right?
Not necessarily. Not necessarily, but I don't mean, I don't understand what you mean that existence can be narrowed to one type of substance. What do you mean by substance?
Let me try to rephrase it. Like,
okay,
what is the smallest component of of reality? Is it atoms?
But it depends on. Here it enters philosophy a bit, because atoms are not the smallest, because you can open an atom and you will find electrons, protons, and neutrons. And then if you open a proton and neutron, you will find the elementary part. So in that sense, elementary particles will be the smallest. But there are some people that think that indeed particles are a manifestation of fields in physics.
Right, that's what I was trying to get to.
So what you have as like a primary entity are fields, not particles.
Right, so that's what I was trying to get to. Yeah.
Yes.
So if the most fundamental nature of reality is made up of these fields,
yes,
how do we say that the way in which we can categorize the world and differentiate between things in the world, are those things real? Like are those if everything is made of the same stuff, like
yes,
where does the kind of confines between one thing and the next take place, if ultimately it's all this field?
Okay, yes, I understand your question. Indeed, I think that fields are not like the smallest, for instance, but then you have space and time. What is space and time? Because space-time, which is because it's only one thing, is more fundamental even than fields. Because in order to have fields, you need space-time. And nobody knows how have a theory class how space-time was. We don't know that. But what we are telling, what I guess that your point is that reality has like levels of complexity. So you have these elementary things, like you can call it space-time or fields. And from those things, then you have particles. And from particles, you have atoms and molecules. From them, you will start to form, I don't know, the stars, planets, and then you have all the level of complexity that is us. And then you have machines, and you can go on and go on. So I guess that the thing is, how do you distinguish between one and the other? And I guess that you have elementary things with properties, and when these elementary things are combined, you have another thing which has an emergent properties that is more complex than the other one. It's like you have different levels of somehow reality. You have a physical level, a logical, you can have a society level, and maybe a technological level, and we don't know if that can goes up and up and up. So
yeah, I guess that's
I think
the thing that
all of that is real, but each of these levels, yeah.
Oh, sorry. You were cutting out a little bit, so
I'm sorry,
I
I
didn't
guess
realize
that I lost a bit the connection.
No, you're good.
Yes.
Yeah, I guess that's kind of one of the questions that I tend to go in circles with a lot, is because I hear a lot about this distinction between the fundamental aspects of reality and the emergent aspects of reality. And I'm often left wondering if these emergent aspects can be said to be real, or if they are in some way illusory, or if they're just more complex layers to the fundamental. Like, can they still be said to be real in the same way, or are they kind of more narratives?
No, I guess that they are real because you for instance, you can take you say a human being, you can say that a being is much more complex than, for instance, an atom. These are different levels of complexity. But would you say that a human being is not real and an atom is not real? No, both are real. I guess that maybe we will have to define what do we understand by reality.
Sure.
I guess. But if they have an existence, a real, well, and here I'm using the word real, they have existence in this world. Could be they have, or maybe, yes, this could be a definition. They have the ability to change. Things that have the ability to change. What defines something that exists in the universe that is different from an abstraction is that they have the ability to change. And yes, so what I was telling you before, a triangle cannot change. It's in your mind. It's an abstraction. Okay. A number is abstraction. Yes. But the mental processes, when you are imagining a number, these are real.
Right. Yeah, that makes sense. Begin to Know asks, is it correct to say that the Kalam assumes the causal structure of space-time to be fundamental?
I
would say so.
That, but this is a bit more complex, because I guess that the Kalam cosmological argument assume is that there is the causality is the way things are related. But the Kalam cosmological assumes space-time. Space-time means that everything is composed of events, and these events have a Kalam cosmological argument assumes causality. But it doesn't. The problem with these arguments is that they do not define specifically what do they understand by causality. You know, you have just these premises, but what do you understand about each of these terms?
Right. Yeah, that makes sense. Yeah, I always found the Kalam to really...
Okay, I guess I lost the connection.
Okay, can you hear me?
Yes,
can you hear
yes,
me?
Now I can hear you.
Okay. Yeah, I was going to say...
Yes, I can hear you.
Yeah, I always felt like the Kalam was just misusing terms and conflating terms between premises. I always found it to be pretty problematic as an argument, even philosophically outside of the science. But yeah, I really appreciate your presentation. I think it was really helpful. I hope that the audience enjoyed it as well. So what else are you...
Yes, of course you can. Yes.
I was going to say, what else are you focusing on as far as like your work?
Well, at the moment, I'm really focused on in more scientific works. Outside the philosophy, but many of the things that I work on have philosophical implications. The things that I study, for instance, I was my last work, I was black holes, and I was studying whether black holes could exist in a universe that goes through a cosmological bounds, the ones that I was discussing there. Suppose that the universe was in a state, started to contract, and then it has a bounce and started to expand. What happens if you have a black hole in the other side of the universe? Could this black hole go through the bounce and emerge in the expanding phase? Well, to answer that question is not trivial in the context of general relativity. And what we found is that is possible. You could have a black hole that goes from one universe or from one phase of the universe to the other phase of the universe, and that could solve some problems that we have nowadays in cosmology. For instance, one of the people in the audience was asking about the CCC Penrose model, that one of the problems of this model is that the entropy of the universe increases in a cycle. And with our finding, we show that black holes could diminish the entropy to keep it in a level that will not increase in every cycle. So when you work with black holes and general relativity, you are working with the edge of space and time. So if you understand more about space and time, you could understand a bit more about some philosophical issues. But at the moment in scientific philosophy, I'm not working. I would like to, but I really don't have the time.
Understandable. Yeah. I'd ask, given its problems, why are theists so excited about the Kalam? I would say it's because most people are not scientifically literate, and they hear something that sounds to make sense and kind of intuitively seems to make sense, and so that's why they're drawn to it. And also,
I agree.
I begin to ask, how does someone who studies GR deeply get involved with something like the Kalam?
Just because I was curious about what science can say about all these arguments that have been disputed over the centuries. So could from science give somehow for me a definitive answer? So that's why.
Is there something funny about time in CCC?
Funny about time in that if something weird happens with time, I don't know if that the question. In the CC model, how Penrose gets to have these cyclic cosmologies, I get that he is somehow introducing some field in the universe that accounts for the universe to have these cycles.
Sure.
Okay, thank you.
Yeah.
I don't know that there were many channels in the Kalam argument. I didn't know that.
Yeah, a bunch of channels have addressed it. I'll definitely let them know that about you, because I think you have a lot to offer for sure. And like I said, I appreciate you coming on, and I thought that was really a good presentation. And yeah, I would love to have you back at some point.
I'm sorry for my English and connection, but if you are interested, you could read our work. I can send you then the link to, or the PDF of our work. It was a paper published in International Journal of Philosophy of Religion. I don't remember the exact reference now, but there you can have in more detail the discussion of the argument.
Yes, please send it to me so I can post it on my channel so other people can go read it as well.
Okay. Yes, of course.
And I had no issues with your English at all. I could understand you perfectly fine. It was just more the internet was a little bit iffy, but it got better.
The internet connection.
It was only bad at the beginning, and then I could hear the rest of the time fine. So.
Okay, better then.
Thank you again so much. I really appreciate it.
Thank you for all the lessons and on the invitation. Thanks a lot.
Yeah, let's stay in touch. And guys, as always, thank you for coming on and listening to us tonight. And I'm not exactly sure when the next show will be. I think it will probably be in a few days. I'll keep you guys posted. And I hope everybody has a great night. And I will see you guys soon.